Yes friends, so conditional probability, the basic definition conditional probability of B when A has occurred is given by probability of A intersection B upon probability of A. As we just described that illustration, what was the illustration? The sum was less than 6, right? Sum of A and B, the two events, or sum of the two dices, digits of the two dice was even number, right? But less than 6. Even but less than 6. So that was coming here 4, and this and probability of A was coming 18 upon 36. That means 1 upon 2 in the denominator. In the numerator we were having 4 upon 36. 4 upon 36 it was coming. By 4 upon 36, the total outcomes were 36, and 4 were common points between this 18 and 4. 4 was common. 4 upon 18 directly we can do, that means 2 upon 9, or we can say that 4 upon 36 upon 18 upon 36. So 4 upon 36 is 1 upon 9. In the denominator we are having 1 upon 2, because 18 upon 36 is 1 upon 2. So 2 will come in the numerator, so 2 upon 9 finally has come. Now in this case, just describing that what is conditional probability. Definition: conditional probability of is this probability of A intersection B divided by probability of A. Okay. So as I just described that probability of A, B by A is equal to this, or we can say that when A has occurred first in this case, or if I say that probability of A by B is also given by probability of A intersection B divided by probability of B, whatever in the denominator is there, that probability comes as the denominator. So this is probability of B. Here probability of B is not equal to 0, must not be equal to 0. This probability of A must not be equal to 0. Then the conditional probability is defined like this. So probability of A intersection B. Now in this case, as I did tell you that in case of dependent events, now these two events are dependent events. So from multiplication theorem, as I defined it, okay, from multiplication theorem as I defined, from multiplication theorem for dependent events. Second part was for dependent events. For dependent events, right? For dependent events, that was probability of A intersection B. It was equal to probability of, let me take A into probability of B, conditional probability of B with respect to A, or probability of A. If it is probability of A, then probability of A in the, or A in the denominator. So probability of B by A, or B with respect to A, or B, probability of B when A has occurred first, or A has already occurred. So this is the basic definition. I talked about dependent events, multiplication theorem, or we are just take this probability of B intersection A here, take PA to this side. This is the same definition. Okay, this probability of A intersection B, but taking probability of A into probability of B by A. From this probability of A intersection B is equal to probability of B into probability of A oblique B, or A with respect to B. So in the same definition, I mean, so multiplication theorem for dependent events defines conditional probability. So that we have already defined in the previous lecture series, but this is the basic definition. We have to find this probability. This is given intersection probability of A intersection B upon probability of A, or N A intersection B divided by NS divided by NA upon NS, means number of favorable events in A in the denominator. Or we can say that when outcomes of A are there, then probability of B when outcomes of A are given, either this is the definition. So conditional probability of B when outcomes of A are in the denominator, total outcomes with respect to the total outcomes of A, or probability of A when total outcomes of B are in the denominator. In that way also we can define, but the basic definition is this. This is the formula for finding the conditional probability. Okay, so conditional probability is calculated by these two formulae mostly. Alright, if there are more than 2 events, for example 3 events are there, then what is the conditional probability then? In that situation, as I have defined, If there are 3 events, then what is the conditional probability? Then out of those 3 events, 2 must have occurred first. Then third is happening. Okay. Then we define those events. In case of dependent events, let me just define it for 3 events. If there are 3 events, then what is the conditional probability? If there are 3 events, A, B and C, then conditional probability okay, for these events is given as suppose we have to find out probability of C. Let me take probability of C when A and B have occurred first is given as probability or condition probability. This is condition probability of C when A and B have occurred first or have already occurred. Let me take have already occurred. So this definition as probability of C oblique A intersection B. This is how we give it. Okay. This is equal to probability of A intersection B intersection C divided by. Now in this case we will have probability of A into probability of B oblique A. Alright. Into probability of B into probability of B, probability of A, B oblique A, and probability of B, right, oblique, no, this, probability of B is not coming, this is probability of A, probability of B by A, into probability of this we have already taken, probability of C, sorry, only these two will come in the denominator. Alright, or we can say that probability of A intersection B intersection C, this value will come here, probability of A into probability of B oblique A has already occurred, into probability of C with respect to A intersection B. This probability of C with respect to A intersection B, the denominator. So this is the, from this condition probability of C when A and B have already occurred. This is given by this formula, or this A intersection B intersection C probability is equal to probability of A into probability of B oblique A into probability of C with respect to A intersection B, or this is combined event A intersection B, or A and B both have occurred first or already occurred, then C is occurring. So in this way, condition probability for 3 events is given. Now for independent events, as I have told you, here they are dependent events. For dependent events, when one event has already occurred, then second is occurring. So second event, probability of second event with respect to the first is known as condition probability, and they are dependent upon each other. So the dependent events are when one has already occurred, then second is occurring, and that second is based on the outcomes of the first. Okay, that is condition probability. So condition probability is for dependent events. That is the basic point. And for independent events, if they are independent, then probability of A intersection B intersection C in this case will be equal to probability of A into probability of B, because B is now not dependent on A, and equal into probability of C, because C is not dependent on A intersection B. In that case, if they are independent, then the multiplication probability of A into probability of B into probability of C will come. Okay, that is the basic difference between dependent and independent events. And as I told you, that mutually exclusive events are generally independent, are not generally independent events, as I have defined here. They are not generally independent events, right? So this is what you call basic definition of dependent and conditional probability. Conditional probability is the basic point here. So what the conditional probability, as I have defined, that suppose one event has already occurred, then second is occurring. So the probability of the second event with respect to the first one, or with respect to the outcomes of the first, is known as conditional probability. And conditional probability, for conditional probability, the events must be dependent. But if they are independent, then conditional probability is not defined. Then conditional probability is not defined. Why? Because then probability of A by B will be equal to probability of A. Probability of B oblique A will be equal to probability of B only. B by A equal to probability of B only, because B is not dependent on A. Right? Sorry. So this is what conditional probability is defined. Okay, finally, let me take the questions second onwards. So these questions are very important. They will define further what is conditional probability. Now let me take question number 2. Here what is given to us, let me first read it and then solve it. It may be a compound event or may not be a compound event. I'll just define by this formula for independent events, for dependent events. Okay, and if they are independent, then formula is probability of A intersection B equal to probability of A into probability of B. With that situation, the probability of B, for example, A by B it is, then probability of B by in the denominator, and in the numerator it was probability of A intersection B, then probability of A intersection B, if B substitute probability of A into probability of B, probability of B cancel out, so probability of A by B is equal to probability of A only. Okay, so in that situation, the dependent events must be there for conditional probabilities. Okay, so basic requirement for conditional probability is that the events must be dependent. Okay, one event must be dependent upon the other. Only then we can find the conditional probability. Condition is given that they are dependent. One event has already occurred, then other is open, and the second is occurring, or second is happening. Okay, so that is how condition is there. This is conditional probability knowledge. Now come to the second question. Question second says, a bag contains 5 white and 3 black balls. Alright. 2 balls are drawn at random, one after the other, without a replacement. We'll find the probability that both balls drawn are black. Now let me take what is given to us. It says a bag contains 5 white and 3 black balls. Alright. Then it says that 2 balls are drawn at random. 2 balls are drawn at random. Okay, without one after the other, they say one after the other, one after the other, without replacement, right? This is without a replacement, no problem, without replacement. Now to find out here, what we're going to find out, you find the probability, find the probability that both balls drawn are black. Alright, solution. Let us take here. Now if one ball is drawn, for example, and if it is black ball, And how many black balls are there? 3 black balls are there. Alright. So the probability will be 3 upon, because one ball is drawn. The drawn ball, suppose one after the other, the ball is happening. The first ball is drawn. What is the probability of that ball? 3 upon 3 plus 5, 8. So total outcomes are 8 here. Let me take here. Here, before the first draw, of one ball, the total outcomes or NS is equal to 3 plus 8. 5 white, sorry, 3 plus 5, 3 plus 5, 8. That is 8 total. So total outcomes is 8 here. And one black ball is drawn. So the probability of one black ball drawn, let me take that event is A. One black ball drawn, or probability of A is equal to how much? That means NA upon NS. Here A denotes the first ball drawn, one ball drawn. A denotes one ball, right? First ball. One ball means first ball. A denotes first ball. This is NA. 3 black balls were there. It is 3 upon 8. This is first outcome. Probability of A here is this. Now second, let me talk about further solution. Now when second ball is drawn, now this is without replacement. So this ball drawn, first ball drawn is not replaced, not put into the bag again. Now this is, lessened from the previous total score. This one ball is subtracted. Now how many black balls are left? 2 only, because out of 3, one ball is already drawn. Now only 2 balls are left total, black balls, and the total balls are 2 plus 5, 7. Okay, so that is how. Now probability of B is second ball drawn. Second ball drawn is also black ball. So the probability of this B, this implies that probability of B or second ball drawn is also black. Probability of second ball drawn is also black. So this is equal to NB upon NS. This is what? So it will give us NB. What is NB here? NB is 2 black balls left upon 7, because 2 plus 5, 2 black balls are left and 5 white balls, so total 2 upon 7. This is the even probability of B. Now, if I have to find out what is conditional probability of, what is common here, out of these 3 balls and 2 balls, only 2 balls are common. So this 2 upon, we can find finally what is the probability here. 2 upon 8, initially 8 it was, 2 upon 8 upon 3 upon 8. Right, 8 cancelled out, 2 upon 3 is the answer. Conditional probability therefore is, let me now find out the conditional probability. Therefore, conditional probability of the second event of the second black ball drawn with respect to the first black ball drawn. Okay, that is how the conditional probability is. How it is given: probability of B with respect to A. We can say here NA intersection B divided by NA. In the denominator is NA. A intersection B in the numerator. What is the NA intersection B? It is 2 upon NA, number of favorable events in A, but 3 black balls only. Initially 3 black balls, and finally 2 black balls, but they are common. Out of 3 and 2 is common. I mean 2 balls are common. So 2 upon 3. Final answer is this. Or we can say 2 upon 8 upon 3 upon 8 probability if I have to find out. This is equal to, let me take probability of, or it could be divided by NS. This is NS divided by NS. This is probability of A intersection B upon probability of A. Can be taken like this: 2 upon 8 upon this number I am just finding out. 2 upon 8, 8 it cancels out. This is 2 upon 3 only. So conditional probability of B, or of the second black ball with respect to the first black ball, that we can say. So this is probability of B with respect to the first event A is 2 by 3. Final answer. Let me take here 2 by 3. Okay, let me again write it down. So probability in this case B second black ball with respect to the first black ball. Write it down is equal to, as I told you, probability of A intersection B divided by probability of A in this case. Or in this A intersection B, because 2 black balls P represent 3 black balls, 3 upon 8, and sorry, this 3 upon 8, 2 upon 7 here. But in this case 2 upon 7 was the remaining balls. Okay, so that was the, if I just take that, if I the intersection value is this 2 upon 7, but in this case 8 was not the remaining value. This is without replacement value. Now if I take that this is probability of A intersection B, because these two are independent events. In this case this is not the final answer. Here let me take here A and B are independent events, because they are not. Why independent? Because the second event is out of 7 outcomes and first is out of 8 events. So this is multiplied, we can say. So probability of A and B. So probability of the compound event. This is compound event here. Compound event. And the probability of A intersection B is given by probability of A into probability of B by A. In that way also we can put here the probability of A was 3 upon 8. This was 2 upon, because this 2 was left over. 2 upon 8, the 7 was left, so this is 2 upon 7 here. So multiply, this is 6, 2, 4, 0. This is nothing but 3 upon 28. This is 3 upon 28. This is the answer here. 8, 4, 7, 28. So 3 upon 28 is combined event here. So this second event is 2 by 7, B by A. And first event was 3 upon 8. Total was 3 and 3 was, so probability of 8 was 3 upon 8. Because favorable cases were 3, total number of cases were 8. In this case it is 2 upon 7. So we have to multiply this. This is conditional probability B upon A. So we can say that B upon A in this case is equal to, this value is 2 upon 7. It must be. This 2 upon 7 here. B upon A is. Okay, then our compound event, this whole event is equal to 3 upon 8, 28. That is the answer. So in this way, this is compound events, because they are not, they are independent events, not dependent events. Or we can say that dependent event, they are dependent events, but in this case dependent events means we have to just find the compound event A intersection B, because that is not given here, we cannot take common from, because that was 2 upon 7 and 3 upon 8 initially. Out of that, common is not given, so A intersection B is a compound event. We have to just multiply probability of A into probability of B by A. Okay, so that is the answer. Now, let me take the question number 3. What does question number 3 say? Let me take that also. Okay, now question number 3, what did it say? Question number 3, let me check what it says. So it is the compound event A intersection B, we have to find out, or probability of A and B. This is a compound event. Second, I think question number 3 is also a compound event. Let me check it, whether it is for dependent event or even dependent event. If it is there, then also we can find compound event. Question number 3. What is question number 3? Third question says, find the probability. Let me write given here. Given. Now it says, find the probability of drawing a queen, alright, a king and a knave. Knave means jack, in that order from a pack of cards in 3 consecutive draws. Try to understand. Again, this is a compound event, right? The cards drawn not being replaced. This is also of the same type. Compound event this is. So that let me take what is given to us. Okay, we are given here that from a pack of playing cards, from a pack of playing cards, what is given? Drawing a queen, a king and a knave. Knave means jack. Knave or a jack. They are known as what do you call? Owner's card. Owner's card. They are known as owner's card, or owner's card. They are known as owner's card, not digit card, but owner's card. Okay, so owner's card there are 4 kinds of card: ace, queen, king, and jack or knave. Right? These 3, queen, king, and knave, one after the other, the 3 draws are done. Okay, a queen, a king, and a knave, jack, in that order from a pack. Okay, in that order from a pack. In that order from the pack. From the pack. Okay, in 3 consecutive draws. In 3 consecutive draws is done. Okay, from a pack of playing cards, drawing a queen, and this is done. Then find the probability. Of drawing these 3 cards one after the other. Drawing these 3 cards, 3 owner's cards. Yes, these 3